Hello students, I hope you are good, well and fine, and today we will be continuing our discussion on probability. We previously saw some terminologies and now here we will do lots of example to understand the concept of probabilities. Okay, so let's move to our first example. So now our first example related to the tossing of two coins. So first of all, make a sample space. So in first toss will give me either head or tail. Yes. Now my second toss, if I am getting head after second toss, first toss. Now after second toss, I'll be getting head of tail. Okay, head was I'm already have head. I've already had, and now I'll be getting either head or tail. Yes. What if in the first toss I got the tail? I got tail. Then in the second toss I have two possibilities again, getting I have already have tail and getting head or tail. So in total, if you see two coins are tossed, if two coins are tossed simultaneously, I have four possibility. One is getting head or head tail head or tail. So four possibilities. Okay, so my sample space is equals to head tail head, or just tail. I hope this is clear. So total number of elements is equals to 4. Okay, now probability of getting two heads, and if you see probability of getting two heads, that means two heads. If you see I am getting two heads only just one time, so the number of favorable outcomes is just 1 divided by 4. Now probability of getting at least one head, that is minimum head we are going to get is 1. So if you see at least one head, that means here we also had one head, at least we are getting one head, here we are also getting at least one head, and here also. So the number of favorable cases is 3 divided by 4. And no head, that means we are getting no head, that means the only case we are getting no head is this case. So the number of favorable condition for no head is just 1, which when we are getting just tail both of the time, so divided by 4. So the probabilities are as follows: 1 by 4, 3 by 4, 1 by 4 respectively. Okay, I hope this is clear to you. So in first case 1 by 4, so the sample space is my this head tail head tail, and probability of getting two head, that means head only 1 by 4. The probability of getting at least one head, that means head tail, and tail head, so 3. And probability of getting no head is just tail. Or if you see from the this that probability of tail is equals to 1 by 4. I hope you are seeing these calculation very easy and very clear to do. So let's move next. Now my another example says about bag of balls. So a bag contains 5 red balls. So this is my bag. So I have 5 red balls, 8 white balls, say 8 white balls, 4 green balls. Now 4 green balls, and 7 black balls. So 7 black balls. Let me use another color for white balls. So white balls will be my this. So white balls. Okay, I hope the representation is very clear. Now if one ball is drawn at random, so I am drawing a one single ball, so find the probability that is a black ball. So probability of getting a black ball, we know the number of favorable outcomes for black ball is 8, and divided by, in total we have 5 plus 8 plus 4 plus 7 balls. So in total 5 plus 8 is 13, 7 plus 8 is 11, which means 24 balls. So divided by 24. So this will give me the probability for black balls. So 8 by 24. Not red. So this means if we are not getting red, that means I am getting either white, either green, or either black ball. So in total the favorable number of terms are 8 plus 4 plus 7 divided by 24, which means if you see this will meet this is 12, and 12 plus 7 will give me 19. So 19 by 24. And for green balls the favorable is 4, and the total is my 24. I hope this is very clear to you. So let's move to next. So indeed the total number of balls in the bag is yes 24, and for just black balls the number of black balls were 7. So number of black balls, so number of, yes, I did little bit mistake here. So number of black balls are 7. So 7 by 24. Sorry for the mistake. So it is just a minor mistake. So let's see the remaining probabilities will be 19 by 24 and 4 by 24. So in this case 19 by 24, yes, 19 by 24 for not a red ball, and 4 by 24 for getting a green ball. I hope this is all clear to you. It was a quite simple and very interesting problem. Okay, so let's move to next. Let's see more examples. Now this question or this examples belonging from card theory. So if you recall, let me recall you cards about cards. So in total 52 cards. Okay, these 52 cards divided into 4 suits. 4 suits. So one is my spade. One is my spade, which looks like this spade. Second is my diamond, which looks like this. Third is my say club, which looks like this. And fourth is my heart, which looks like this heart. Okay, each of them in numbers are 13. So 13, 13, 13, which in total gives me 52. Yes. Now if you see the diamonds and hearts are of red color, so this means red cards equals to 26. And for black cards, these are my black cards. So black cards is equals to also 26. So 26 black cards, 26 red cards, in total 52 cards. If you see from this black and red perspective. Now if you recall the face cards, what are the face cards? J, Q and K. We know 4 cards for J, 4 cards for K, Q and 4 cards for K. In four cards, one is of spade, diamond, club, and heart, and same goes for them also. Spade, diamond, club, and heart. Spade, diamond, club, and heart. Okay, I hope this is all clear to you. And in total, I have 12 face cards. So 12 face cards are there. I hope this is all clear to you now. So let's move to our example and solve it. So our card is drawn from a well shuffled deck of playing cards. Find the probability of getting a face card. So in total we have 12 face cards. 12 face cards. Okay, so this means the probability will be 12 by 52. A red card, we have 26 red cards, which means probability will be my P is equals to 26 by 52. I hope this is clear to you. So the in first 12 by 52, because the 12 face cards are there, and for next it is the red. I misunderstood, I think, the question. Let me see it again. So yes, so we are just talked about red face card, not just red card. So if the question were saying to me a probability for red card, okay, so probability for red card, and we know 26 cards are red, then P is equals to 26 by 52. Okay, so this question, or this is the probability for red cards, okay, is equals to this 26 by 52. 26 by 52. Okay, but in this question it is asking for red face card. Okay, so red face card, we know we have 12 face cards. So 12 face cards, and each of these 12 face cards are of J, 4 of J, 4 of Queen, and 4 of K, and from each of these only single is of red, sorry, only two are of red color. Two are of red color, which are those the diamond and the heart. So 2 plus 2 plus 2, which is equals to 6. So in total I am getting 6 red face card. So let me give the details. So J of diamond and is red, K of diamond and heart is also red, Q of diamond and heart is also red. So red face cards. I hope this is clear. So in total 6 red face cards. Okay, so now, so answer for this will be my 6 by 52. I hope now it is clear. 6 by 52. I just misunderstood our question. Okay, so now I hope this is clear to you. Let's move to next. Now let's solve with me some exercises to polish your concept. So now we are tossing 3 coins, okay, simultaneously. So let's toss it. So first attempt, in first time we are either getting head, we are either getting tail. Okay, now in second time, so this is my coin first time. Okay, now a second time, second toss. Okay, I'll be getting head is already there. I'll be getting head or just tail. So in similarly here the second time what if in first time I got tail and I tossed again, I have already tail and got head or just tail. Now for the third time, let's make more branch, head, 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 head. Either I am getting head or tail. For this, head, tail, head, head, tail, tail. And for this, tail, head, tail, tail, head, head. So this will be my head, or this will be my tail, tail, head, tail. And for this, tail, tail, head, tail, a tail, a tail. If you see, the number of total possibilities are 1, 2, 3, 4, 5, 6 and 7, 8. So in our sample space, the sample space will look like what? This head, 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 tail. This whole uh, these are all belonging in our sample space. So I am just writing few of the elements. So in total 8 elements are in sample space. I hope this is very clear to you. Now what? Now if we have to find out the probability of getting at least 2 heads, so at least 2 head, I am getting at least 2 head, that is minimum number of head I want is 2. So in this case I am getting, in this case is also this case, 1 2 3 4, just 4 cases. So the number of favorable outcomes is just 4, at least 2 heads divided by the total number, so which is 4 by 8, which is 1 by 2. So option D is my correct option. So yes, indeed. Let's move next. Now question related on cards. Now 2 cards are drawn successively with replacement. That means if I have a deck, so this is my deck of 52 cards. So I am drawing successively 2 cards with replacement. That means if I draw 1 card, okay, I am got 1 card, then I put it back into the deck and then again draw another card. Okay, another card. So what will be my probability in this case for getting 2 aces? Okay, so here if you see in first attempt, so first attempt in first attempt you the probability of getting 2 aces. So in first attempt you draw a card, so probability of getting 1 ace will be, so the number of favorable outcomes for ace is 4 and the total number of outcomes are 52. So the in first attempt I am getting this probability and I return this card into the deck and then again got a chance to draw another card. So the next time the probability remains the same. Now what? So this happening of event and this happening of event both are independent to each other. That is, one is not depending on other. So in this case we just multiply both of the number and we will get 4 times 4 by 52 times 52. That means 4 this cancelled 13 times. This will also get 13 times. So 1 by 13 times 1 by 13 will give me 1 by 169. So the probability will be A 169. I hope this question is quite interesting for you. Okay, you give yourself a time to understand it and make your efforts to do it by yourself. Okay, let's move next. In a single throw of 2 dice, so we are throwing 2 dice, the probability of getting more than 7 is, so probability of getting more than 7, what it is? So So we are talking about probability of getting a more than a 7 in a single throw of 2 dice. So what we are getting is this: we threw 2 dice. Okay, now probability of getting more than 7, that means we are asked for the sum of uh, the sum of the numbers. For example, let me make a table. So in first throw, 1 2 3 4 5 6, and this is will be my second. So 1 2 3 4 5 6. So 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 5, 1 comma 6, 1 comma 7, 1 comma 8, 1 comma 9, 1 comma, sorry, not 1, this will be 2 comma 1, 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5, 2 comma 6, 3 comma 1, 3 comma 2. I am writing without commas now. 35, 36, 41, 42, 44, 45, sorry, 43, 44, 45, 46, 51, 52, 53, 54, 55, 56, and 61, 62, 63, 64, 65, and 66. So I have to find out the probability of getting sum. Here must be the sum of the numbers more than 7. So if you see from this, this sum is more than 7, this sum is also 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 more than 7, but here it is just exactly 7. So we are taking more than 7. So this this and this, for this and this, and this and this. So 1 2 3 4 5. So in total I have how many possibilities of favorable outcomes is 5 plus 4 9, 9 plus 2 12, 9 plus 3 12, 12 plus 2 14, and 14 plus 1 is 15. So favorable outcomes are 15, and in total what is my elements in our sample space? So these whole numbers written in orange or separated by comma is my sample space. So if you see, the sample space contains 36 elements. So probability for this is equals to the total and outcomes is 36, and the favorable outcomes is 15, which will be my, if you take common things out, so which is 15 times the 5 times 3 and 36 is 12 times 3. I can easily cancel out 3, so 5 by 12. So option C, 5 by 12 is my correct answer. So please make this thing that we are talking about the sum more than 7. Okay, sum more than 7. So let's see. Yes, indeed our answer is correct. So let's move to next. So this problem is also based on the previous type of problem. Let's solve together. So 2 die are thrown together. Once again we are throwing 2 dice. Now the probability that the sum of 2 numbers will be a multiple of 4. So here we are talking about that the sum we are getting is a multiple of 4. So let's write down our sample space. So in sample space, 1 comma 1, 1 2, I am not writing comma, just writing it 1 3, but it is understood that the comma is presented here. So 1 4, 1 5, 1 6, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, 3 1, 3 2, 3 3, 3 4, 3 5, 3 6, 4 1, 4 2, 4 3, 4 4, 4 5, 4 6, 5 1, 5 2, 5 3, 5 4, 5 5, 5 6, and 6 1, 6 2, 6 3, 6 4, 6 5, and 6 6. This is my whole sample space. Okay, now what? Now just see what are the pairs whose sum of two numbers will be multiple of 4. So let's try to see. So here, so 2 plus 2 is 4, yes, multiple of 4. uh, 2 plus 6 is 8, multiple of 4. uh, 3 plus 5 is also 8, a multiple of 4. And 3 1 is also a multiple of 4. Yes, now 4 4 is a multiple of 4. Now this is 5 3 is also a multiple of 4. This is also a multiple of 4. This is also a multiple of 4. Let's again verify. So 1 3, this 4, yes, a multiple of 4. Okay, so 1 6 and a 7. This is my 3 4 5 6 7 8 4 5 6 7 8 9 5 6 7 8 9 10 6 7 8 9 10 11 7 8 9 10 11 12. So yes, these are the only favorable outcomes. So in total, 1 2 3 4 5 6 7 8 and 9 total favorable outcomes divided by 36. So 1 by 4 will be my answer for this. Okay, so let's see. Yes, indeed, the 1 by 4 or the option C is my correct. Let's move to next. Okay, so in a cricket match, a batswoman hits a boundary 6 times. Okay, so out of 30 balls, so she hit only 6 balls out of 30 balls. So this means in my sample space, the total number of outcomes are 30. And okay, this is clear. Now the probability that she did not hit the boundary is 30 minus 6, which is 24. So 24 times he misses the ball. Okay, so she did not hit a boundary on 24 balls. Okay, so this means to find out the probability, so probability for not hitting not hitting a boundary is equals to the favorable outcomes, which is my 24, and the total number of outcomes, which is my 30. So by solving it, this means 6 4 is 24 and 6 5 is this, and this is my 0.8 if you see. So this will be my answer, the option A. I hope you understood what the question said. And let's see. Yes, indeed, our answer is A. So that's all for today. I hope you learned new approaches, how to find probabilities. You remembers the theory for cards and what are face cards and different, and sample space. How do we find the sample space for tossing of 3 coins, tossing of 2 coins, throwing 1 dice, throwing 2 die together, In the similar way, you can also find out sample space for throwing 3 dice. Okay, so I hope all things were very clear. So let's meet again for in another lecture. So thank you.